So this zombie enemy is ready to attack our hero character. Maybe 150 lines of the C++ code behind it. No blueprint spaghetti, no third-party AI plugin used. In this video, I'm going to explain you how exactly I built it in Unreal Engine 5.8 using C++. Hey guys, welcome back to the Game Dev Mania. I'm adding a new episode to this YouTube Game Dev series. So this is a Hollow Gate, a third-person zombie survival game I'm building solo in Unreal Engine 5.8. In this video, I'm going to start with the hero character animation system, and then the enemy class hierarchy, and then the AI controller and the spawner class. I'll walk through everything in this particular, barely in this particular order, the way I build. So before explaining any gameplay code, I would like to show you a small recovery script that I have built. If you have worked with the Unreal Engine C++ or any length of time, you know the pain. Like you rename a class, live coding get confused, and then suddenly your blueprints won't compile, and it shows like it's corrupted. So in order to recover the .dll files, I have write a fix build.bat script. So let me walk you through this script. So this is the script automates the fix, closes the editor and deletes the binaries and the intermediate folders and kicks off the face build. Cheap insurance worth doing on day one of any project. So without further ado, let's just go ahead and open our Unreal Engine editor. And I'm going to show you what were the classes that I have created here. So roughly in this order. So first of all, I have created a hero character. I've already shown discussed in the earlier previous videos. So these are hero character, and with its animation instance. So I have created these are hero character animation instance, and driving to the blend spaces. So I've already I've already created the blend spaces as well. So if I go to the blueprint class and the hero blueprint class, and these are these are animation blend spaces that I've created. Going forward to the C++ here. So 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 these are enemy based abstract class. So basically these are parent class, because we are having two type of enemies here. One is zombie and um, one is the boss character. So all will be inheriting from the enemy base class. So enemy base class that holds shared health and the combat logic, and a concrete zombie character. So this one is an AI controlled character, and so there is an AI controller for the zombie character as well. So likewise, I have created our parent enemy class, enemy base class. I have created a enemy base AI controller class as well. So our zombie AI controller is inheriting from this enemy AI base controller class, and also we can see we have created a zombie spawner. So whenever our hero character here, so if I hit and play, uh, you can see when I enter this zone, these zombies are appearing here. So for these functionalities, I have created a zombie spawner. So it will trigger the zombies to appear in the gameplay and follows our character. driving into our actual animation here. So you can see these are hero character anim instance .cpp file, and these are hero character anim instance .h file. So the hero character u hero character anim instance class, as you can see, it's inheriting from the u anim instance, and this is the C++ half of the animation blueprint. In the Unreal Engine, an anim blueprints graph can be baked by a native C++ class that does all the math, and the graph itself just reads the results. That exactly the split I did here. So let me go to the Unreal Engine here. I'm going to show you the animation blueprint class for our hero character here. So this is the ABP hero. This is the ABP hero. Give me a sec. So this is the actual animation blueprint asset, and you can see this is the parent class of this blueprint class is our hero character anim instance C++ class. And you can also see in this variable section, if I can expand this. So expanding the variable section here, so you can see all the variables that I have exposes in the blueprint from our hero character anim instance C++ class in order to use this variable in our anim graph and the event graph. Okay, so you can see this is the velocity forward, velocity right, speeds, velocity z is falling, is crouch, is stacking. So so if I go up here, you can see I have set up everything in the anim instance, and it's these are all being exposed in our Unreal Engine blueprint class. So moving forward to our C++ class here, in the header file, we can see I'm using two functions which is there to override our functionalities in our CPP. These functions are I'm getting it from these two functions are already being defined and declared in the uAnim instance, the parent class of our hero character anim instance. So so if I go to the CPP file here, so these are the native initialize animation function, which is being used to run once and caches the pointer to owning a hero character and its character movement components. And this native update this native update animation, which is having delta seconds as a argument, is runs every frame and does the actual work. So each frame, it takes the character's wall space velocity and transform into a character's local space. That gives me the velocity forward and the velocity right. So we'd be needing the velocity forward and the velocity right separately, because we are going to hook these values into the locomotion blend spaces instead of just single scope speed value. I also compute the horizontal speed here to track the vertical velocity for the jump and fall blending. and also pulling the B is falling straight from the movement component, plus B is crouch and B is attacking straight from the character. So all of its blueprint read-only classes. So if I go into the anim instance dot header file, so you can see these are all blueprint read-only classes. So what does it mean? So it does mean that our graph can read it, but nothing in the blueprint can be accidentally overwritten. The C++ value, the values which C++ is computing in every frame. So the math only happens in one place. So moving forward, so the take is that this is the pattern setter. So the native classes plus the blueprint pattern. C++ owns the math and the data. Blueprint owns the graph and the art facing tweaks. This is exactly what I'm going to carry into the enemy classes next. Let's move into the zombies. So this is the enemy base class. So as I've already discussed earlier, we'll be having a parent enemy base class because we are going to have two kind of enemies in this game. So one is the zombie one that we're going to create here, and another we'll be creating later videos, which will be the boss. So this is the enemy base class and it's marked as a U class abstract. So basically what does it mean? It means you never mean to place this directly in the level. So it's a base for the concrete enemy types, and you can see it's straightforward a character subclass with three things: health and attack function and the on death function. So the health is simple. I have three things for the health. One is current health, second is max health, and third there is a take damage overridable function which comes into play when it take damage. I clump the current health to 0 and max health to 100. So if I go to the CPP, when when it take damage and the 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 current health becoming, when the current health is less than equal to 0, I call the on death. If I go to the enemy base.h file here, so you can see both attack and on death functions are blueprint native events. That means that C++ only provides a default implementation. So what does it mean? It means like any blueprint that inherits from this class, this can override just the function without touching anything else. Same idea as the hero anim instance. Write the skeleton and the save defaults in C++, and then tweak the specific in the blueprint where it's actually the first step to iterate. So um, so there is the on date implementation here. So if I go to the definition here, so it is doing exactly what you would expect in the on date implementation, right? So it flips this variable b is dead flag to, you know so the damage or any attacks stop landing, and then it's disabling the captured collisions and kills the movement of the character, and plays the death montages if there is any, and also it's setting up this lifespan to 5.0. So what it does mean, it means if the character is already dead, you don't need to it doesn't need to literal in the level for forever, so it can cleans up after 5 seconds.
Okay, so let's move into our zombie character. So these are our zombie character.cpp, and this is our zombie character.h, means the header file. So I deliberately keep it tiny. It inherits from the enemy base, and it just sets some concrete stats. If I go to the .cp file, you can see it just sets 150 health, 20 attack damage, 200 max walk speed, and all the actual behavior already lives in the parent class. And this is just a pattern that I want to keep it using, because in the later part I wanted to add more enemy types. Um, if I go to the if I go to the our Unreal Engine editor, let me know. So yeah, so you can already see these are BP zombie character class. This is the blueprint class, and this is the parent class, the zombie character, the C++ class. And I also have two more blueprint class. One is BP zombie fast and BP zombie flat. Sorry, fat. So if I open this class here, so you can see the parent class of this class, the BP zombie fast, is BP zombie character. I so this BP zombie fast and flat, these blueprint class are actually the child class of this blueprint zombie character. So if I go to the viewport here, you can see we have like three types of zombie which is going to attack our hero. So these kind of a cop character, I like it because I saw it in the Mixamo, and this character I really like, and I wanted to have it in our game, so I put it. And this is another type of the zombie. These are a girl character, and there's another type of zombie here. So basically, we have three type of zombies. All right, so so let's move forward with the enemy base AI controller .cpp and enemy base AI controller dot header file here. Um, let's go to the enemy base AI controller .cpp file. So what is interesting here is the enemy perception component that I'm storing in this enemy perception variable. So what is the enemy perception? So this is the component for which um, we'd fill our zombie into the I mean we'd fill the zombies live in your gameplay. So this AI perception component is created with the site config, and our site config is having the site radius to 4000 4000.0. Site config also have the loose site radius, peripheral vision angle degrees to the 90 degree. Set the max is to 5. um, Also, I'm instructing the site config to detect the enemy and detect the naturals, but don't detect the friendly lies. Like it should not detect the other enemies, the other similar enemies, right? So this is how we set up our perception. So moving forward to on pauses. So I bind a callback to on target perception update, and I start repeating the timer chase target firing every 3 seconds. I am deliberately not doing this in every tick. Zombie doesn't need to, frame a perfect reaction. So that's why I don't keep it, you know, with a tick. So moving forward to another important stuff here, which is chase target. So chase target itself has a fallback if the perception hasn't found a target yet, or I mean it does a direct distance check against the player pawn, and is a cheap safety net in case of the perception hasn't fired yet right after the spawn. So what it does once there is a target, if it's outside of the loose side radius, the zombie gives up and stop chasing. Otherwise, it walks on or run towards the player depending on the distance. And once it's within the attack range, it stops and call try attack. So this what this chase target function is doing. It's also our attack. It's also plays a attack montage and starts a cooldown timer before it can attack again. Okay, so let's move forward to our zombie AI controller class. These are zombie um, zombie enemy AI controller header file and the zombie enemy AI controller CPU file. So it's a thin subclass of the enemy based AI controller class, and it's following the same pattern as the character class. So the zombie enemy AI controller just override this try attack function here and set the zombie specific number like 120 attack and range to 2.5 seconds cooldown. All the actual chases and the perception logic stays in the base class. Okay, so now we'll be moving towards a zombie spawner. So these are zombie spawner CPP and zombie spawner hair file. So uh, basically, the zombie spawner is actually the responsible. This class is responsible to actually getting the zombies into the level. So the so if I go to the Unreal Engine editor here, so these are zombie spawner, and it's if I so this is got dragged into the level directly, so we don't need any blueprint class out of it. Okay, so let's move into the our zombie spawner dot cpp file here. So in the constructor, what we can see here is actually the zombie spawner is an actor with a box component, and its roots sets to a trigger collision profile. And on trigger overlap, what we can see here, we are checking if whenever an actor overlaps the trigger, I mean overlaps this box here, our zombie spawner here. So it checks whether it's a actual hero character or not, and also it checks like if the if the event got triggered or not. I mean, this zombie spawner got triggered or not. So if it's the hero character, and if it's not triggered already, then it's instructing it to set the B has triggered to true and spawn the zombies into the level. So now we know how our zombies are spawning, okay? Like on which condition is spawning. But one thing we're missing is that where a zombie should appear. So for that, I'm using a navigation system called I'm using this particular function here, this get random reachable point in radius. So when a zombie spawn, it should always land on a valid land, right? So it should be a walkable mess instead of potentially spawning a zombie inside a wall or maybe off a ledge. Okay, so this is it. In the next video, we are going to see how this AI evolve. So thanks for watching. See you in the next video.